So thanks for coming, guys. We'll I'll hand over to Roland to kick it off. And sorry for the delay. It's everyone gets delayed by Windows updates sometimes, you know. So over to you, Roland.
Good to see everyone here again. It's nice to be around. This time, as I mentioned, we're going to be talking a little bit more at the other end of the spectrum. So we're going to be talking about the ecosystem that makes up a React application in modern web development. Everything from file splitting, bundle splitting, to routing and how that's managed across, single pages or single page apps, or if you're doing things like hash things and hash-based routing, as well as how testing comes into the whole sort of framework for building a React app, and how we can leverage the React technology suite to provide an ecosystem that provides a really iterative, fast, deterministic testing so that we can ensure the app that we've written keeps working over time. So I'm just going to jump ahead a few of these slides for those of us who followed on from our previous session. I'm going to start talking about a single page application. So for those who aren't familiar with what a single page application is, it's the idea of one piece of code that is able to be manipulated to represent various states, i.e. pages, without actually making another full request to the server. Now, I've got a couple of questions here. How do we treat our app as a sequence of pages? Maybe we want to display different sort of sequences depending on where users clicks. Do we want to, change the contents of our page? Do we want to, maybe trigger an event on the page? And how can we make these various states of our application that represent the different pages accessible directly, like a URL grants? So how do we give something that can be shared so we can share the current view state of our application with third parties, someone else over the internet? So traditionally, when you look at a standard sort of application, web application, you type an address into your browser, makes a request to the web server does whatever it wants to do, gets some HTML, pumps it back to the user looks through the page, goes, oh, that looks like a good link, I'll click on there, the URL changes, and the process repeats itself. So it'll go back to the server, request the new data, give it the new referrer, and the server will come back and say, hey, you've got a new page. And it does that from start to finish every time we iterate over the pages. However, with a single page application, that very first page request will load everything we need for our application to exist. So theoretically, on that very first page load, we've got everything the user needs right from the get-go. So if we want to change pages, we can actually change the URL natively, but we don't have to go to the server. We can just do everything natively on the web page without having to do any requests. We literally don't even have to tell the user we're changing it. We can choose to with the URL changing to identify that something's changed. But we get this control mechanism to paginate, if you will, across various URLs and provide various states for our application to look at. So I've got a nice little question. What if we could instead load everything at once? So one page load for their entire app experience and allow the user to navigate around without needing to load everything again. And this is one of the features that HTML5 actually brought to the equation. The idea of this history object that was made available via JavaScript, which gives you the ability to push objects and pull objects to reference the user going back and forwards through their history. Now, the reason these are so interesting is that they can actually change the location bar. If you're familiar with using the old school JavaScript, window.location.href will pull down whatever's in the address bar. But every time we change this previously, it would have to go to the server. But by using these HTML5 technologies with history, we can actually push an object on without making another request to the server. And good old JavaScript gives us a nice little handy function which actually lets us listen to these changes. So because we can listen to these changes, every time that URL changes, we can re-trigger in our application something that detects a page change and go, hey, user's not where we thought they were. We've now got them on a new page. Let's reload some content for them. Let's present something to reference this new page. And when you look at push date, it's actually a really simple concept. It takes a couple of objects, basically a URL to put in the browser, location bar, a state object which has a bit of data to define the new state that you're moving to, and a title to reference what's there. And that's really as simple as it is. You can push as many times as you want. And then you can even leverage the JavaScript history back and forward programmatically to bounce along this sort of list or array of locations that you've got in the address bar. And it's as if the user was going to brand new pages every single time along the pipeline. So it kind of runs on history push state, where you add to this array of history objects that your browser knows about, and history replace state. So you can actually completely keep your history to one level deep and just keep overriding where the user thinks they are. Also, of course, this sort of approach. So again, because we can programmatically change the address bar, and we know it won't request any data, and we have a means to track each time the address bar is changed, we can build a single page application that can span as many URLs as we want without ever going back to the server after the first request. So when we're looking at routing in React, there's bucket loads of libraries, like everything for these sort of things in the community. React Router Component, Mini Router, Router 5, but probably the most well-known version is React Router. It got a lot of interest very early on. It's been picked up by various libraries that leverage React, and it kind of adheres to that great paradigm that React really encourages about the idea of reusability, componentization, where everything you build, everything you release can be leveraged in the same way for different courses. So this library is actually fantastic because, as you'll notice in the image, it has a web version that uses the same API. It also has a React Native version. So if you're building React Native applications, you can actually leverage the same router that you would use on your website to get the exact same code and the exact same experience across both your user experiences. So if you have React Native on their phones, the exact same code base is what you're using for React on the websites themselves. So I'm primarily going to be looking at React Router version 3. Version 4 is the latest version out at the moment. It's a complete rewrite. It's lightning fast and adds all sorts of really funky new paradigms. So things such as the fact that you actually can do your routing individually. So normally with React Router, when you do your routing, you have a top level route that kind of, every time the page changes, only one place can detect whether or not anything is going to shift over time. But with React Router 4, you can actually keep doing these sort of checks on the routes, and all across your application, depending on what the route is, change various parts of your application state individually as opposed to the whole. So there are two types of routes that can be used. One is hash routing and browser routing. So keeping it very, very simple with what we have there, hash routing is the idea of using hash bangs to track whatever the URL might be, a different sort of reference for each page. And browser routing is actually using the fully qualified sort of URL string. I do need to point out that this only works on the same origin. So if you change the domain for any of your links, React Router will just say, hey, it's a real link, we got to go somewhere else. But if it's on the same origin, it will keep tabs of that, keep the location tracked, use the HTML5 history push state, and keep that tracking along. So there are three key components that make up the route management that you have in a React app, and especially if you're using React Router. So you have this top level router, which is basically an encapsulator to say, hey, everything under this component is going to be listening for events that change the URL and will be reacting accordingly. Then you have a route. Now your routes are the individual sort of page references that you want to potentially change your output on. So the component that you want to render. If you have a look on the right-hand side, you can see I've just got a little routing example. You can see I've got a top-level router, a bit of code underneath to show a few links. You'll see I'm leveraging this link object in there, which of course ties back into React Router, so it can listen to see, check that you're on the same domain and the same origin, and use that to actually manage the push state. And then I've got three routes identified. So I've got a root path. My base page component will be rendered whenever that's matched. A page 1 and a page 2, which is going to have two separate components to represent each of those pages. You'll see I've got a big note at the bottom about the fact that version 4 is missing some of the features of version 3. These include things which I'm about to talk about shortly, such as the way it does bundle splitting and the way it does sort of individual tracking. It's actually synchronous, completely synchronous version 4, which is why it gets some great speed improvements. But it means you lose that sort of ability to dynamically load pages as you're going along the pipeline. So that brings us back over to Webpack bundles, splitting and optimizing our bundles. So we've talked about routes, we've talked about the fact that we want to have, potentially a really complex application structure. We might have, in the case of Agoda, we have, hotel pages. If we were a property website, we might have a list of various properties. These can span hundreds and thousands and millions over time. So we need something dynamic that's going to, let us load each of these individual components as the user requires them. So as the application gets larger, obviously our file sizes get larger. We've got to deal with the libraries we're using. React is, of course, a perfect example like that. We might be looking at things like Redux. We might be looking at React Router. We might be looking at things like Moment to handle our time zone management. We use Lodash to help with, some of the JavaScript style features. Suddenly, we're looking at just our library alone is, maybe 1 or 2 megabytes before we've even started looking at our application and page-specific logic. Then we've got things like our shared resources. A lot of libraries these days will try and do sort of embedded images and things like that. They'll try and embed CSS. If you're looking at CSS, they'll try and embed that directly into the JavaScript. And of course, that increases these bundle sizes. So before you know it, you've been adding all these components to your application, and suddenly you're asking each of your users to download 8 megabytes just to start accessing your website. You might want to change that. So what about the contents we want to have that are specific to a particular page? What about contents that we might want to load dynamically, lazy loading? What about content that we actually want to load asynchronously as the user hits the page because we don't want that initial load to be impacted? How can we do this? Now, is anyone here not familiar with Webpack? Awesome. Webpack is basically a bundler at the end of the day. What it'll do is take a list of files that you might have, and you can programmatically set conditions such as, I want to load all files in this directory, I want to concatenate them, I want to put them through a transpiler like Babel, I want to do, for every file that ends in, let's just say CSS, I want to extract them to separate files. I want to have different entry points to my application. It gives you this configurable ability to choose how files are grouped together and bundled up for delivery or development. It's quite a flexible sort of idea. Gulp and Grunt, task runners by nature. You talk about this more as a bundler as opposed to sort of a task tool. But its goal is to actually group everything you put together and present something you can use at the end and deploy to a production system. So the answer to this problem of how do I take my application and go, hey, I need to get something in there, I don't want to load it all in once. And if we are familiar with the sort of ES15 sort of ideas of require, it's got this great ensure function, which we can actually use to define our split points. And it's really quite handy because what it does is it gives us the ability to return a promise that we can resolve at the end and use to output a component on the page. So if you're using ES6, there's still a bit of debate in the old community and the standards about how dynamic libraries are going to be loaded. They've kind of said import is the way to go right now, but I've noted there it's not 100% approved. They've said it's the current standard. So personally, I just use require. I mean, I like using ES6, but I know this works every time and on every library, so require is my option for that. So what happens is we've defined our code. I've got a little example here. Variable A, require A, variable B, require B. And then if you look at the require ensure set of code, it takes an original object an array that I can define, and then I pass it a function to pass when it resolves. So what it's going to do is pass the require function, which is again the require that we had in the parent. And we're going to say we want to require something from B, a little maybe function that's out of that require. But then I also want to require D. And what happens here is Webpack actually will have a look through our code, because that's how it works. It runs through the code and sort of looks over what's there and tries to transpile it and goes, hey, I've got a require ensure file. So on the right-hand side, you'll see it's got this little Webpack JSON-P split chunk, which is basically all your code wrapped in a JSON-P wrapper that Webpack gives you that can then be sent back and forth on request every time your code requires that file. And Webpack is smart enough to work with ES6 and ES15 libraries to say, hey, we've got a new bit of code. we've got a promise. So we're going to execute our promise. We're going to say we're going to display our component. Here's my little module. I'm going to execute it right now. And so it gives us this mechanism for dynamically loading files within this wrapping ecosystem that can be transferred across domains, that's why it uses JSONP, and easily embedded back into our pages. So we've talked about the route, and we might want to have various pages that are defined statically. We might want to have our help page, our login page, our home page, all defined in the original package that every user gets. But then they might transverse through the application and come up to something like, in the case of a real estate website, a property. So we've got the property URL and we go, hey, okay, they've hit the property URL, but this is a really huge chunk of code and they're probably not going to hit this straight away. I'm going to use this get component function, use this require ensure, and dynamically include a completely compiled React library and component that I can then embed straight away in the page. And what it gives us is the ability to set breakpoints all throughout our code, all the way from the route, which might be page specific, or we could go further and actually do split specific, where every time we include a component on one of our pages, we might load it dynamically. So in the case of something large, we might have a page that's, just figuratively speaking, 18 viewport screens deep. Now, do we want to load that entire set of data straight away when the user hits the page? Probably not. But what we could do is have a split point in the code for anything that's underneath the fold where the user is focused straight away. And as we detect the user scrolling down the page, go, hey, we've hit 2/3 of the way down the page, we've got a really heavy bit of code coming up down here. Let's start loading it before they scroll the next third of the page and hit it there. So it gives us this ability to set these dynamic breakpoints to actually dynamically load the code of each of our components, and it is done at a component level, dynamically load each of those components on demand. So it takes them out of our original bundle size. So we get a much quicker way to put something in front of the customer before they've even had to go all the way through the funnel. Now, if we were using React Router v4, because it's synchronous, we actually have to add our own component to it to actually handle this dynamic inclusions. So you have this sort of idea of a bundle component, which will be passed some property, basically a module. And what it'll do is it'll take the component that you want to reference, look through the code and go, hey, hold on, I found my little split point, and I'm going to go, hey, I need to load this in, include the module, and run it through there. So you can see I've got my bundle loading on the right-hand side where I've defined 2 routes, a base page and a page 1. And you can see I've got this bundle wrapper that has an import passed to it. And that import is that ES6 dynamic loader. And what it's going to do is say, hey, here's another promise coming through, send through this import. Once the import resolves, execute the component on the page. So it gives us the same features we had in React Router v3, but you can see it's a bit more code and a bit more effort to get the similar functionality. It does work just as well, for the record. It's just obviously a little bit more complex in how it approaches it. But what's really interesting to look at here is this is how you would do lazy loading. By wrapping components that as they're viewed, doing the dynamic import and doing it on demand. Each time you loaded these components that you had to load, you could load them every time you executed rather than at the parent page before anyone's actually looked that up. This is one of my favorite topics to talk about. Anyone here ever played with Redux before? First things that comes to mind when you're using Redux. Throw some words at me. What's the first thing that comes to mind? State management. Perfect. So application-wide state management. So because again, we've got this idea now of a single page application where the user's potentially changing their URL over time, we've got to manage that state over each of those page transitions. Now, if we were doing it at a component level, every time we change the parent component and demounted it, we lose all that original data that we just spent all this time loading. We might have hit a third-party service and loaded, let's just say, 0.5 megabyte worth of data that we needed to transverse and sort of display to the user. Now, we don't want to lose that. because the user might go forward to a page and then come back. Or we might look at something like a global thing, such as the user's profile details. Once that's loaded, we want every single component in existence in our application to potentially have the ability to say, hey, is the user logged in? What's their name? Do they have these features? Or we could go a little bit further and we can look at something like application-wide visibility state. Is an overlay currently being displayed on the page? Are we loading a third-party resource of data? Are we still trying to wait, processing a request that they've made? And we can use these states to actually keep all of our application aware of things going on, even though there's no connectivity between those components. So Facebook introduced this idea of Flux, which is this one-directional channel for passing data through to your component. So it's based on 4 principles of an action, a dispatcher, a store, and a view. Now your component is the view layer in all of this. But when we move it back, the best way I've ever thought of visualizing this is an action is a trigger or an event. So a user clicks on a button, so we need to do something. So the action itself is some event that's triggered within your application. Your dispatcher is how we know that this event has taken place and how we keep that visualized throughout the state of our application. We need a store to actually keep track of all the things that are changing over time because of these actions being dispatched. And then finally, we need to render that to the user. But that's the original Flux sort of architectural overview. Redux is kind of an extension of this. And you can see with this diagram, it takes a very one-dimensional sort of traversal path and actually splits it off a little bit. And it's about the idea of side effects sort of catalyzing themselves within your application and the fact that it will listen and pump the data back into your views over time. So it starts with this idea of an action creator. So an action creator is what triggers your actual event. So if I click on a button in my component, I might want to initiate some action, so I want to dispatch that action to my listener. So if you follow the path that's up there, you have an action creator that creates an action and punches it into a dispatcher. Now the dispatcher will say, hey, this is going to happen, and it will pass some data along. It'll have a unique name, like a type, and then it'll maybe pass some data, maybe the result of a AJAX request along with that sort of action. And then we have this reducer, which says, hey, this event's been triggered. What have you passed along with me? So I'll go back to our property website idea. Now we've requested some data from our backend. It might have a featured image of the property. It might have the name of the property. It might have a unique ID. Now all of those we want to store. We might not want to store all of it. We might want to ignore half the data that came through the request. But everything we want to store, we want to punch into our reducer. And that reducer will keep track of what's going on there. So once that's been reduced, it has this effects handler. I mentioned side effects. Basically, every time any data is punched through a system, things are going to change. So anything that changes is called a side effect. And these side effects can keep triggering these actions. And the reason this is so interesting is it's this idea that your app begins to repeatedly, over time, dispatch actions and listen for these events. So every time something happens, your application is reactively, I keep saying react, or reactively, your application is listening for these changes and updating accordingly. So I'll go through in more detail how that kind of works. Everyone okay with the way this is going so far? Awesome. So I've got a little example here that I've done for a to-do list. Everyone loves a good to-do. It's the simplest way to describe a lot of sort of moving pieces. So in Redux, I mentioned that actions are like messages. They're the events that sort of trigger these events. So every action in Redux requires something to identify the event that's being driven. So generally speaking, for those wanting to do things, you'll look at here and you go, remove request. I've got success and failures. And what I'm doing is I'm dispatching events to highlight that something has taken place. So in this case, I've got a remove public to do, where I have, I immediately dispatch the fact that I'm actually executing a request. So remove public to-do request. And here I actually make an AJAX request using my to-do service, which is a promise. So you can see the then underneath. And inside that promise, I have a look and make sure that I've got something that's come back. And I go, hey, the request status was what I expected, 204. So I'm going to dispatch the fact that it was successful, and it was successful for this ID. If it failed, I might emit a failure message and give it an error message that can be displayed to the user. Now, if we had our components all tied together, we'd actually have to be passing these messages all the way up the inheritance tree. We might have a component executing this 55 levels deep, but we want to show an error at the top of the page. By using something like Redux, we have a central means to store that, execute it on a button on an arbitrary page, and the global sort of store, if you will, can have a little component that's an error component that's just listening for was error thrown. And it can pick that up straight away and display it in almost real time as it happens. So, sorry, I've heard someone. So as you can see, I break up the request into 3 moving pieces. The fact that I initiate a request, the fact that my request was a success, and the fact that my request was a failure. And this gives me the control over how things are structured. You can dispatch as many things as you want. The idea is to have a central means and a central messaging pattern that allows us to track changes granularly over time without overriding them. So when we look at reducers, we look at the idea of taking some data and putting it in a form that we want to keep over time in our application. So what we can do is combine reducers to create an object that tracks into our stores. We use this idea of a combined reducer, so we can make a really nice complex object that allows you to build up your store. And the way they work is they take an action and they take your previous state. Now, with these two, we get, we can have a look at the previous state of our application and go, hey, we just made this request 20 minutes ago, still got the data in the store, and it's identical. We probably don't need to do any changes, so we can discard what's going on. Or we might have an array of events that we might want to just add to over time. Gives you this flexibility of choosing how your state is sort of evolved over time. So yeah, they take your previous state and allow you to modify the previous state to generate a new application state. And the great thing about reducers is you can listen to as many actions as you want. The general pattern that's kind of used is usually a switch statement, because the way it works is that every single reducer is technically listening to every single event in your system, but you probably don't want it doing something on every single event in your system. So of course the default is to keep your state identical. But for the cases that we do want to work on, we can define our cases and then return the new state that we want to pop in there. Now, the big thing to always mention when working with Redux, especially when comparing it with other technologies, is it's the idea of a single store solution. Anyone familiar with the idea of single store and multi-store? Basically, a multi-store would be the case of I'm going to have one unique little thing holding my user data, and that lives over here. I'm going to have another object holding my application state data, such as is a window open, a modal open, or a pop-up open. I might have another state over here, which might be the current property I'm viewing for my real estate website. But with Redux, we actually do it all in the same object. And this just makes it a little bit easier to keep track of where things are over time. Because if we have multiple stores, we have to keep passing multiple stores. We don't know which one we want to access. So this package gets a lot of grief about the fact that it simplifies things so much. But that's also a lot of the strength of it, is that it makes you realize that you're working in a single entity. So you need to optimize and sort of look at how you're structuring your data. So I mentioned the fact that Redux is always listening. And for those who were here a couple of weeks ago, I talked about the idea of higher order components, which is the idea of taking a component and wrapping it around another component to return a new component. That's pretty much how Redux works. It has this connect component, which is basically has its own state in the React sort of lifecycle idea. And what it does is it keeps listening to each of the states and messages going on over time. And every time one of those states changes, it punches them through as new properties to your component. So here we can see that I've got two functions defined, map state to props and map dispatch to props. And what these two functions do is they give us the ability to manipulate the properties of our component with something from that parent Redux store. So in the case I've got example, I've got a to-dos object, which I'm going to pass back as a property, which I'm going to pick up from the application state. And I've got this dispatch to props. And what it means is I can actually add a function as a property that I can use to actually dispatch events later on down the track. So every time you update a Redux state, the component's going to start triggering some of its lifecycle events. And the really important one that it's going to trigger is should component will receive props and should component update. For those who followed along a couple of weeks ago, component will receive props, takes the previous properties, and lets you do something based on whether or not that's actually come through. And should component update actually lets you debounce this whole idea of updating every time your properties change, or forcing the properties to change over time. So because we know that they're listening all the time, and I do apologize, I am talking quite a bit, because you know it's listening all the time, you've got to be aware of the fact that this has a heavy overhead. So every time we make a component and we've got this big, Redux store over time, we need to think what parts of that store our component should be listening to. And importantly, do we actually need to listen on every component? Or should we only listen at a higher level, some sort of ancestor component, and then pass those properties back down through the tree? Because every time we listen to each of these changes, the more objects we listen to, the more chance of a triggered update. And we don't want that to necessarily happen all the time. So the best way to visualize how your application state is going to be there is to think of a good old JSON object. All it is at the end of the day is a JavaScript object. So it's a good opportunity to think about what parts of your application you actually want to put in there. Do you want to have things like the current user data? Once it's available, you don't want to have to keep passing this all the way down your component tree. Application events that change the display, so overlays. When we're loading data, we might want to put a placeholder image that says, hey, loading data from a third-party resource. Or we might want to have some data that reflects some previous events that have taken place. We might want to have this list of every time a user modified a property. We might keep a running archival history of each of the changes we made. So you've got to think about structure. And again, this is getting nice and technical here. We've got to think about the structure because of the way that Redux and React compare properties, the idea of shallow and deep comparisons. So if we make a really complex data structure, it actually requires us to do really deep comparisons of our object over time to track whether or not changes come through. Obviously, the more complex we make this, the slower it becomes over time as this state gets bigger. So we want to have really shallow objects as much as possible. And a really easy way to help with that is to group by domain, because it gives you a way of sort of identifying what similar properties are being used, how they're being modified, and to make sure that everyone is using the same domain property all the time. This way, anyone who's changing data, there's only one place to change it. Don't get the same data in multiple places. Same data is always visible, single place, and loaded in. And I've got two examples in there. I've got a bad example at the top. It's not really that bad, but you can see the fact that it nests quite deeply. The fact that I've got a couple of properties in there. So the modal open, I have to go 2 levels deep. Loading data, a couple of levels deep. But if I make this really flat, the shallow comparison can fire straight away and pick up changes without having to go deep to check if anything's changed. It's just a simplification sort of structure. Everyone coping all right? I know it's a lot of talking, this one. We're actually going to jump into a bit of code very shortly. But it's one of those things, it's really good to kind of just go through and understand all the things that are taking place to kind of bring all this ecosystem together. Server-side rendering and isomorphic applications. So does someone want to tell me what an isomorphic application is?
An app that can render on the server, or
Sorry?
an app app that can render on the server or on the browser?
Exactly that. It's the idea of an application that if rendered on the server and if rendered on the client is identical. So it means it can, everywhere the app is viewed, server or client, it will match identically. So because React is designed with client focus, why would we want to look at loading things on the server? What sort of benefits are we going to get? There's obviously some benefits for having the same experience on something that's rendered and something that's generated on the client. I've got a couple of examples there. Why would the SEO matter? Why would SEO be impacted by having a isomorphic application?
Serving real content to that Google bot.
Sorry?
Serving real content to the Google bot instead of the empty.
That's pretty much it in a nutshell. That's one of the biggest reasons, actually. It's making sure that the content's available straight away. The second is actually speed. The ability to actually serve your HTML almost near instantly without having to load a HTML stub, execute JavaScript, go down your complex tree. It gives you a massive speed boost for those initial loads. And the third one is static content generation. So with static content generation, anyone who's tried to do newsletters or mailing lists or anything like that in Node.js, gets a bit painful trying to get all your variables, kind of put them together, tie them together. But what if we could use the exact same stuff we were building on the client to build the same page, load the same CSS, use the same stylings, use the same components, even load the data from an external resource. We can do all this with server-side rendering and an isomorphic application because we can trigger things at various points that leverage all the strengths that we gain from React on the client in terms of the componentalization and actually just use them in the same way on the server. So there's two functions that come for this. One is render to string, which will basically, for a given component, will go down the entire tree, mount every single part of the component, and return it as a HTML string. And this includes all the React data bindings, which are like properties on your HTML component like data-React ID, and that's React's internal ID for each of those components. Excuse me for a second. And the reason this is so powerful is when your client-side code executes in the browser, so you've already rendered everything on the page, your client-side code comes in and executes and goes, hey, all the HTML's already there. I'm not going to run my render function. I'm just going to quickly bind all my events. I'm going to get my click events, all of that, because I've got the React IDs, super fast. And then you have your render to static markup, which is the exact same function, except it stops all the React bindings. So you don't get your React data IDs put in the DOM elements. You don't get any of those executions. It literally just runs through, gets the HTML, and returns it in a chunk. Now, this is perfect if you want to do things like HTML emails, if you want to do things like newsletters, or if you want to create a page that can be embedded in the third party without having to load heaps of libraries. So you can use the server-side rendering, render your really nice complex React component, and then serve it up on a third party without having to worry about the libraries. I've got a little bit of code on the right here, and the reason this is interesting is this highlights exactly how this kind of works on the client and the server. So if we follow through, you've got your usual HTML definitions, a few headers sort of being defined at the top. We've got this div ID app, which has the component HTML, an initial state for our Redux store, which you can see it'll stringify an object, and then the create app script, which is the actual JavaScript that we're going to execute for our application. So for anyone looking here, what would happen when we run this on the client directly? If we were to run this on the client, what would be the execution flow and how would this happen? So factoring in for the sake of it that component HTML could be empty, initial state might be empty. Can you see what's going to happen? I'll give everyone a few seconds on this. The answer is absolutely nothing. I saw a few heads shaking. That was it. The answer is absolutely nothing. it's going to go through, execute as per normal. Nothing will be input inside that div ID equals app because component HTML is empty. The initial state's going to be empty. And then it's going to run our create app script, which is our React code. So it's going to run through and go, hey, there's nothing in place on our page. Well, we're now going to mount our point, and now we can start executing our code as normal. Whereas on the server-side execution, we can generate that component HTML using the render to string function, punch it straight in there, immediately displayed to the client. In the window.initial state, we can pick up, and predefine some object to define our state, maybe the user, maybe whatever page they're on, and punch all that in immediately. And then create app script runs, and it will go, hey, div ID app's actually pre-populated. Well, I don't need to do anything right now. I'm going to follow down the track and start catching on to all those React data IDs, but I'm not going to change the DOM. And this gives it this huge performance benefit on doing that first load. And it means what we have is the exact same HTML is served to the client and bundled on the server. So it can work in either scenario, depending on whether or not data is available. And it's this flexibility that really gives it such a sort of desire to sort of be leveraged, because you can control, all parts of that life cycle by choosing where you want to run it. Server, client, completely up to you. There's a big smile on my face on this one. Automated testing and development with Storybook and Jest. Anyone used Storybook here before? Great, one hand, two hands, a finger. Storybook is basically a visual UI component sort of library. It's a way of listing all the components that you have available. And Jest is just a test runner by Facebook. Nothing too drastic or exciting about them as they start out, just part of your normal toolkit. But when you integrate everything together and you start bundling it into your component development lifecycle, and you start bundling your tests in, and you start bundling in this whole idea of a catalog of reusable components, you've got this means of kind of working in harmony with various developers, because you can actually work on components independently, keep updating the code base together, and keep track of what your mate is working on as it goes. So a key point is that a reusable component should be easy to find in your application. So it's a component explorer at its heart, a way to list all the components that you have in place that allows for the easy management and identification of components, and kind of gives you a few tools to kind of leverage that environment, around documentation, display, how you might modify over the time. And it really drives home this idea of the fact that React is a component library. It's about making small reusable components that can be passed around to various places in your application and that can be tested in isolation. So the reason it's so interesting is things like the support for hot module reloading when you're building your application. Instead of setting up your complex environment, jump into Storybook, build your component in isolation, and you get all the HMR support. It allows you to list all the various states that your component might exist in over time, so you can keep track of how you want it to evolve, and more importantly, identify that it's in the right visual state. You can integrate it with a test runner, as I mentioned, such as Jest, which means you can actually run your tests in real time as you're developing your code. Now, from a sort of speed point of view, if every time I'm making a change to my code, I can not only see what's changing with my code instantly, but I can actually see if I'm breaking my tests, this would reduce the likelihood of buggy code kind of making it out into the market. And it's got quite an extensive library. You can do everything from real-time snapshot testing, where you're actually taking a visual screenshot of your component over time. You can integrate it with things like GraphQL if you wanted to look at things like that and actually see how your data would change as it passed through to your component. You can integrate it with, obviously, the test runner, documentation and markup libraries. Pretty active ecosystem. And of course, Jest is just a test runner at its heart. Parallel testing is one of the things that makes it so interesting. So you've got 8 cores on your CPU, Jest will run 8 tests at once. It's got code coverage built in, so you don't have to keep adding different things over time. It's got really good mocking functionality, so easy to sort of test, how things are changing and running initially with your application. And the usual sort of matches list. I can check if it's equal to something, if it's not like something. I can check how many times something has been executed. I get a lot of control over that when I'm writing my tests. So before we jump into actually having a look at all of this together, I want to pose the question. So what goes into writing a good test? And good tests, we all want to pride ourselves on being magnificent developers. I'm sure we're all guilty of writing shocking tests over time, in the bid to get things out fast enough. But if we took a step back and said, what do we want to do? How do we want to write our tests? How do we know that they're going to be strong, deterministic, and keep that baseline over time with our application? And the preemptive thing I really want to drill home here is the idea of being deterministic. So it's got to be concrete whether or not your test succeeds and whether or not your test fails. If, I've got a few things here that sort of, considerations to keep in mind when writing a deterministic test, but, the data that you're passing through to your tests should not be stagnant. It should be constantly covering every single scenario, every edge case that you might want to have, because you want to make sure that every scenario your code is meant to meet doesn't get met. So data randomness. Doesn't have to test them all at the same time. You might have a list of 250 use cases, but every time you execute your test, you might only pick one of those use cases just to make it more efficient and fast. But what you want to know is that as your test runs over time, it's going to hit all of those test cases. Now, if it fails any of those test cases, you've already failed the first sort of idea of being deterministic, in that you're not guaranteed to pass every one of those tests. So by putting all those test cases in there, we know that it's going to pass through. The state of your application over time. Every time we build a test for something, we need to not make assumptions about what the application state is going to be. In the case of, what's a good example we can think of? Overlays, perfect example. So I have an application and an overlay, and I want to test whether or not my overlay loads up and the user clicks on somewhere in my overlay, and I want to check that the data is going to change, maybe a date picker or something like that. I'm going to check that the data gets changed to the new date. Now, I've got a really complex application here, and I've got all these things that are popping overlays all over the app. Now, if for whatever reason, something comes along and has a higher Z index than my overlay, suddenly my click event's not going to do anything. Now that doesn't work. That means my test is no longer deterministic. It means I can't concretely guarantee that it's going to run because of these things I'm not accounting for. I'm not aware of the environment that there might be another overlay in there. So anything that changes, we should be looking at, ordering the events of our tests so that we can control the flow. And this is usually a pretty concrete strategy, making sure it's a sequential series of events. And the other one is the idea of tear up and tear down. So every time a test is run, we're going to build up and go, hey, this is the criteria that my test is set for. It anticipates that there's no overlays in my website open. It anticipates that the user is logged in, and it might anticipate that they're on a mobile device, for instance. So we can set that up before we execute our test, and that happens just inside our test itself. And at the end of it, we can offload those. We can remove those changes that we made. We can unwind the user being logged in. And of course, because we want to test this on a real system. So we can run these commands to build up and build down our test case as it's happening. Third one, external systems. So if our test has to work with any external system, and when I say external system, it can be a third-party API, it could be another component, it could be anything under the sun that's not our component, we need to know whether or not our test is going to work. And we need to account for the fact that if there's dependencies, that our test is going to tell us that these dependencies are what's actually failed. So we need to think about the fact that if we call a third-party API, and the third-party API returns 500, that's got to be the error message our test gives us. Our test should tell us that a third-party service failed. This is the way we can know that it's deterministic again, because we get a guaranteed output that is based on what's going on. Ooh, excuse me. So we can use that to test. If it's components, we can check whether or not a component state is set. We can check whether or not a logged in component says the user is logged in. We can check whether or not a overlay component has the open state. We need to know that if any of these are conditions for our test running, then we need to test for those conditions. And we need to make sure that if our test throws the error, we know exactly what it is. So good error messages. And this is all about that final part of the test, documenting the outcomes. So anytime our test fails, we should always be able to explicitly state exactly why it failed. There's always going to be that environment where it's like, could not click button. It's a pretty handy error. I might have 20 buttons in my component that I'm trying to test. Not really too concrete. However, if I said, could not click button 13 identified by ABC because click event picked up the fact that there was another overlay over the page. The second that triggered, I know exactly where to look for my code. I know exactly what element was wrong, I know what it tried to click on, and I know the fact that something was overlaid over that. So I can go back through these steps and kind of go, cool, okay, I need to control the fact that there was an overlay open in my test. Easy way to fix, and we can step through.
Sorry, guys.
That's all right.
Yeah, the Z index is something that pops up a lot.
Hugely.
Yeah.
So it's painful.
It is painful. My intrigue is, are you keeping track of the overlay object in reference to the Z index, or are you just? How do you know that one Z index is higher than the other? Are you keeping track of the component and the?
So you wouldn't be keeping track of that, but within our test itself, what we could do is say trigger a click event.
Right.
Now, when we trigger the click event, we might have some property inside our component that should be changed. Now, if that property isn't set immediately after, we know that the click event itself hasn't been tracked. So that's our giveaway that something has intercepted that first click event.
Right.
So while we can't, we could look around the page for that, but that means the testing isn't localized to our component.
Right.
So what we want to do for those scenarios is go, hey, this is what's expected to happen. This hasn't happened. Cool, set a warning flag.
But it wouldn't say you clicked on this component instead. That wouldn't happen, right?
No, because your testing would be localized only to one component being active at a given point.
When you explained that, I was just like, oh my god, this guy's a wizard. So I had to ask.
Thankfully, not that crazy.
Okay.
So this is just a quick screenshot. I'm actually going to jump right into Storybook right now. And what I'm going to do is actually show you what that development experience is like when you tie in Storybook to give you your user handling, and your error handling, and your test handling all in the same interface. So if you bear with me for 1 minute.
Another cool advantage of Storybook too is it works with React Native.
Sorry, mate?
Storybook works with React Native.
It certainly does. And again,
Test your components on the device as well.
Again, this is the same idea of that reusability. The thing I love most about React is that literally if you're doing mobile dev in React Native, web dev, you can use the same components, the same scaffolding, the same libraries all together. And if they're designed well with that idea of componentalization, reusability goes straight through it all. So you're never actually changing how you work because you're using the same tools for both development, and you get this great sort of shareability in there. And I'd really like everyone just to have a quick look at this. This is available in the repo at the moment. And you'll see that I've got this specifications tab at the bottom of my page. And you can see I've just done a few tests here because this is actually hooked up to Redux. And I'll give you a quick, very basic example. I'm going to add a to-do. Hello. You can see it's actually a fully running piece of code. You can see that this is updated. Everything clicks as per normal. And I've got these tests at the bottom. Now these tests are obviously only executed the first time that it runs. So because I've got this hooked up as a live example, it's not going to keep listening for the changes within there. However, what if we were to change a bit of this data as we develop this over time? That wasn't me. Okay, this is horrifyingly small, so let's make that horrifyingly big. There we go. So you can see here I've got a couple of demo items. Again, really basic example. I'm just throwing a few things together to show them off here. And you can see I've got these tests listed for the to-do list here. 5 items should be in the list, 2 items should be selected. I'm testing an action, what happens when I emit these actions. I'm checking my reducer, again, that Redux idea where I'm checking, whether or not when I add something, is the reducer returning that object? But just starting really basically, what I want to do is show you how this is actually built into my development experience. So what I'm going to do is quickly Alt-Tab here, just reload the page for the sake of it. You can see my specifications show 4 green ticks. Now, where I am in the code right now is I'm going to take one of these to-do items away. Now, if I take that away, immediately, without me having had to reload the page or anything, my test has failed. Because my test conditions, which I defined, the data no longer matches that. So I've got it here that I should have 2 items selected. Again, I can jump back, just modify one value, hit save, and you can see, again, it's running over my code as I'm developing it and modifying it and checking whether or not my test cases are being executed. Now, what this gives me over time is I can work on my component and maintain the fact that I need to have these test cases met at any given point in time. So if I want to change, for instance, I'm going to have a look here. I'm going to highlight this piece of code here. And you can see it's an action code. So this is the Redux idea. And what you can see is I've got this little list of action that I want to expect, where I'm going to add a to-do, I'm going to give it some text, and I'm going to give it a counter ID. So why don't I change this? Why don't I take away the ID, go back to my code, and you can see expected, immediately errors. If I'm changing any of the form of any of my code, immediate references are given to me on the screen. So it's a really quick way to kind of work with your components over time, and it gives you the ability to focus on tests that are literally isolated to your component at that given point in time. Now I'm just going to stop there for a minute. Any questions with anything I've kind of shown off so far today? So this represents a fun time. So what we could do is a little bit of a workshop. We can jump in and start playing with a few bits of Redux. We can start playing with a bit of maybe some Webpack splitting. Where's the interest at the moment?
I'm interested in how you load the page dynamically, so that
Dynamic loading?
yeah, with the
Awesome.
React 4 seconds.
Do you have a copy of the repo?
I think so.
Oh, wonderful. I'll do it here. If you've got the repo open, if you go to this client.jsx file, which is underneath the app, the routes.jsx file, sorry. And you'll see I've got a few routes defined there at the bottom. So what we want to do here is we want to make a dynamic route. Do you want to do it as a dynamic route, or do you want to do it as a component?
I don't know anything.
Okay, well, let's do it as a page. Pages are fun. Okay. Bear with me for a minute. I'll sit myself down. So, can everyone still hear me? Okay, I'm actually going to turn this off while I do this, just so I can shout out. Can everyone hear me all right? Awesome. Okay, what we're going to try and do is we're going to look at the idea of using get component. If I bring us back to my presentation, I want you to have a look at what's going on here. You see how I've got my route, my index route, and then I've got the third route there, the name with page 1 and path 1. You'll see how it's got that get component function. Now, what's going to happen there is it's going to basically execute whenever the route is executed. So we'll go through this together. So we're going to make a new page. We need to make a new page that we want to display in our application. If anyone thinks I'm going too fast, yell out and I'll slow down. So we need a brand new component. I'm going to call it dynamic loaded, and I'm just going to make this pretty so it's easy to read. And what I'm doing, I have to pass two things along here. And these are the location and a callback. The location is important because what it means is that we can actually, on all our dynamic routes, actually take advantage of what the location is at that given point in time. The location is like a window.location object. So it's got everything from the path, the domain, and we can actually pass these either through to our component, or we can use them to determine which of our components we want to load. So there's two steps we have to do here. The first is we have to create the page. So what I'm going to do is I'm going to go into my pages folder on the left-hand side, make a new file. I'm going to call him dynamic component. And because I'm exceedingly lazy, I'm just going to copy a few of these lines. Actually, I won't do that. I'll keep it very, very simple. Dynamic component page. We can keep it very simple, just to make sure I don't forget anything, because it's always embarrassing when we forget things. That's a real lot of thunder and lightning out there, isn't it? Well, the good news is there's lots of pizza and people are eating it, so please feel free to grab some while we're doing this, because now I want pizza. How embarrassing. You can never spell right when you're under the heat. I'm going to do a really basic component. I'm just going to wrap a div with a h1. So I've made a new page that we want to display, which is our dynamic component. I'll give everyone a couple of seconds. Wow. Everyone's got umbrellas?
Nope.
You might be stuck here for a while. So what we want to do is we want to come over here. Oops. And we want to call require.ensure. Now this lets us create references and pass through a function that's executed at the completion of the promise. So we're going to call require.ensure. Now I don't want to pass anything through originally. I want to pass through the require object at the back. I want to call callback, which is what's called whenever the first function completes, and it gives us the acknowledgement of it. Now here's a really good technical question for you all, actually. Sorry if I'm jumping back and forth. So, question. With that require for our component, why do I have to call .default?
Because it's a hash. It's an object, so
Basically, yeah, you get an object that comes back after the require, and with the way that React exemplifies its functions being executed, default is the expected output. So if we just call require, and you look at the returned object, just going to be a JavaScript object that does nothing. But the default part of it gives us back our component. So what we've got written there, this is actually a huge fingers crossed moment for me, I'm doing this blind. Can everyone see what we put in there? So we've got require.ensure, we pass through our promise to execute, we have this callback function that you can call once everything's loaded, and then we have a unique name just so we can reference it in the future. And we defined our path as well, dynamic-loaded. So if you will excuse me for 1 second, and I try and find my little command line prompt, I might just have to change this and actually execute my code. This is going to be a bit of a fingers crossed moment, so bear with me.
The code guards are angry, obviously.
Yeah, they don't like me doing this. So that should be okay. Let's just jump back in. And we need to go back over here. And the URL we wanted to add was dynamically loaded. Now, I'm not holding my horses, but this should be... Well, I got a lovely error. Do you know what I'll do to make this easier? Because I absolutely hate coding up on a screen at a time like this. With this repository, in the next 48 hours, I will pump through 2 examples of how to do dynamic includes using import, which is the ES6 import, and using require.ensure. And I'll also add a brand new page in the to-do list, which will have all the Redux objects in there. And the final part is I'll show off dynamic loading within a page itself. So doing asynchronous loading as you scroll down a page.
Is it because you're not returning the actual component in the dynamic component.jsx?
Sorry, there was a door post.
Yeah. I don't know if you can hear me, but
Yep.
I think you did not return the actual object in.
I probably didn't. That should be coming through from the export. Dynamic component page.
So
Should you do a return of the component?
Return
the keyword return.
Ah, return. Shouldn't actually matter. Truthfully, it shouldn't actually matter because that way. Even if you had that, it shouldn't actually matter with the requires that come through.
In the render.
In the render, Man, this is why I don't like doing this stuff at night. I'm glad you pointed that. Way too tight. Give this another go. This is why it's handy having other people's eyes on it. There we go. You'll see that there were 2 files executed here. See how it has o.dev? And you can see the chunk names that have appeared. Thank you so much. You made my life much easier there. You can see the chunk names. Let me just increase the font size here. This might be a bit difficult as this isn't actually scaling. But for those who can see, you'll see these chunk names. And you can see that dynamic component is now inside that chunk name. So when we reload our page, we have our dynamic page loading. Now, here's where it's going to get interesting. What I'm going to do here is go to the inspect network log, reload. And what I want to have everyone look at here is I'm going to clear this, and I'm going to go to one of our existing pages. No requests. Single page, so no requests are made. What I'm going to do is add a link to our dynamic page, because if I type the link into the browser, it'll trigger a full page reload. Now again, this is one of the important things about single page apps, is identifying that when something is typed into the browser location bar, it will always trigger a page request. That's why this HTML history object is so critical. So let's go to the home page. Where's my dashboard? Under containers, I have a dashboard. There we go. And let's add a new object. What was our URL? Dynamic loaded. You can see the hot update has triggered. Doesn't actually do anything. Dashboard link is not defined. Good to see I can't spell. Now, two things to note here. You'll see how the markup, I've now got this error about reusable markup. This is because React will actually tell you if what you produce on the server doesn't match what you produce on the client if you're using isomorphic loading. And because we did a hot reload, the client has deviated from what we sent in that original request. So if we were to restart, that error would go away. So if we go back to the network list, I'm going to clear everything out, and I'm going to link through to our dynamic page. Everyone see what just happened there? We've now got a brand new JS file, which is wrapping with the Webpack injection. And you can see all these sort of properties that are in there, all the sort of bindings to make sure it can be executed. That all comes along with the file. But you can see at the bottom that we just dynamically loaded a page, completely separated, a couple of lines of code, and we did that on a URL basis. Pretty good. And then also very appreciative for people actually paying attention to me trying to code. And there you have one dynamic page.
Now this is with the development, so now what if you're statically building your site?
So if you're statically building your site, you'd have to keep doing the execution every time. If you have a statically built site to the point where you're just outputting the HTML and the CSS files?
Getting a bundle.
So even when you generate the bundle, so once you compile it all, the Webpack itself isn't actually doing anything different here. What it's actually done is created two files in the compile directory and just basically identified them internally. So the original Webpack bundle keeps that reference to 0 being the very first include. You can actually name that the chunks if you want. So inside Webpack you can say when chunking, use the class name for instance, and it'll give it a nicer name. But for now, just keeping it at 0. But yeah, so you could statically do the build, and you'd see there would be two distinct JavaScript files that are minified in there. One would be the main bundle, and the other one would be our dynamic chunk. Awesome.
Can we pass data to the component that we load this way, or like state, or can we share?
So if we want to pass the state, here's a really fun question. Yes, we can. Now, if we're passing through the state, if we go back to the code, the first parameter can actually be an object that you're passing through. Now, I would never actually call a dynamically included component with properties. I'd actually use something like Redux as the wrapper for that, because of the fact that you don't want to have these weird sort of properties being amalgamated through that sort of sequence. But if you were to do it, that's the place to kind of wrap it in. Callback, the first one's an error, actually. The properties have to be sent. There's actually an annoying thing. I'm trying to remember. There's actually an annoyance. The first callback property is actually the error object. My apologies. It's a bit harder to pass through properties as props. And I can't tell you that off the top of my head right now. Sorry. You tend to try and do it to isolated components for that reason. Sorry, just looking at it going, wow. I'd use Redux if I was doing that, because I'd try and split at the highest level possible for it. But if it was something I really wanted to pass through, like some environmental variable, I'd probably actually wrap the component that had those environment variables in that, and then pass on that way. Anything else from anyone? Hello.
Hi. Could you walk through a bit, pretty much completely unfamiliar with React other than your introduction last time?
Yep.
So I pretty much get the idea, if I'm understanding correctly, with Redux, you have like one state object.
Yep.
That's passing through essentially your tree of components.
Yep.
How does it all wire? I mean, so to separate the components have their own state, which is their internal.
Yes.
The
State's actually a bad word to use,
but
yeah.
method, so that's kind of how the things can flow through. How does the Redux state sort of affect the components? How is it wired up?
So the awesome thing is the states themselves, the state is actually the misleading word in this. The state of Redux is stored completely independently in its own state, separately. But when it passes anything through to a component, it doesn't actually impact on the state of the component. It only does them as properties.
Right, but it does it through properties. The components they should control their own state. It should be
exactly.
private. Okay.
So that way you get it as the properties are immutable, so controllable from that parent level down, and the application or component level sort of changes its state. You never have to worry about anything sort of setting that over time.
So how does it all get wired up as far as, so essentially all the state management is how to say, pipeline say through Redux, right? That should be the only entry point to these state changes.
That dispatcher.
How does it get from there, from Redux to the component?
Awesome, and I'm really glad you mentioned that. I'll quickly jump back to the slides. Make sure everyone can see this. I really want to focus on this one, the syncing your component. So it uses this higher order component called connect. Now connect is just a function that it comes with Redux, so you have to import it from the Redux. And what it does is it gives you the ability to pass through two objects. The first is a state to props, so application level state into props. And what that does is that listens at the very top level for anything changing in the application state. And because the lifecycle events are that you have this higher order component, so it's wrapped. Hold on, I can model it really nicely for you. Think about a bit of code. So something like this idea of this wrapping component and this wrap component. What actually happens in the life cycle is, I'll just draw some code. It actually passes them through as properties, but it uses the state and the fact that render So I'm going to fake Redux in as few lines as possible. We can basically spread them across, or we could do, just for posterity's sake, something like that, where matched props would use that first function I mentioned. The map state to props would pick that out of the child and go, which of these do you want? Because the parent uses its life cycle and goes, hold on, I'm updating, it'll actually re-render the component that we've wrapped in it every time the state changes and pass through new properties as it changes. So it's just listening to the state changes at the top and then punching the render function over and over and over again every time anything in that application state change. Does that help?
Yeah, I think it makes sense.
Yeah, it's trying to simplify it very, very quickly. But it just listens and just keeps re-rendering.
Essentially, Redux is registering this wrapper component and injecting the props.
Exactly that. It's a higher order component that just keeps changing the props that it passes through.
Okay.
Yeah.
Hey, ask about connect function.
Yeah.
Sometimes I see instead of map dispatch to pop function, map dispatch to pop, I used to see they pass the function directly.
Yes, I mean that's one way to do it. So sort of passing them through directly as it is. This is just I like the idea of wrapping the functions a bit because you get a bit more granularity with how you call them. So on to do click, I could literally pass through just on to do click. So let me just replicate that idea. See if I can find what page that was. Private to-do list. So what I could actually do is, I'm just going to highlight this part of the code. And this is the reason I haven't actually wrapped it directly, because I might want to do something with the ID. I could have my toggle to do always have the same definition that has to have an ID coming through. But what about those use cases where maybe I want to do multiple dispatches, purely hypothetical? It entirely depends on how you want to structure it. This is actually more than acceptable way to do. So you can see I'm just passing through it as, there we go. You can see it's basically just the signatures changing. All I like doing about that is I get a bit more granularity to kind of go, hold on function, maybe I want to do some tests before I execute and do my dispatches, because dispatches can get expensive if you keep doing them. I could do error checking to stop the dispatch actually firing altogether. And it means I can control the logic everywhere that I need to. So, I mean, I could very much easily do all that logic in a central way, but sometimes the logic might change on a page-by-page basis, and this gives you that granularity. Exact same solution, just probably mine's a bit sloppier. All good? Awesome. Anything else from anyone? Hey.
Do you have a plan to move on the router 4?
Do I have a plan to?
Move from the router V3 to 4?
Yes, I do actually. I anticipate for this particular library, I will have that done in the next week, I would say. One of the things that I will actually be launching a few notes on, and especially in this repository, is how to leverage server-side rendering with initial data loading and population, and actually doing the dispatch that we did, all those Redux actions, and tying them all together for an initial page load. I'd say give me a week or 2 weeks to punch it up, but we can put a note on the meetup when it's available to everyone, and you can jump in and have a look and critique my code. Awesome. Well, that takes us to 10 to 9, so I might wrap it up there. Any other questions? I'm hoping it's not raining for everyone. Feel free to eat more pizza. Anything you don't eat, I will. Fantastic. Thank you very much, everyone, for coming. I hope you enjoyed this as a bit more of a transition from an entry level to the other complete polar opposite of the bit more sort of advanced ecosystem level.
Is the previous online?
Yes, and this slides section, everything that's in the slides includes the entire previous section.